Good news for those that hate the unit circle. We will not be using the unit circle for a little bit. All right, no real inverse problems or stuff. This identity section can be tricky or it can be easy. It kind of goes back to each section of Precalc I think of. Either you overthink things and make them really, really complicated and your life becomes really complicated, or you just stick with the basics. All right, just follow the script that I provide you. Don't fight it. Don't go, this has to be way more complicated than it needs to be. Don't. This section is all about rewriting things in other ways that make them simpler or allow me to solve a problem. Now, for instance, we already did basic identities. We did it in 5.3. Because in 5.3, I'm going to skip down here really quick. Remember we did sine squared plus cosine squared equals 1? Do you all kind of remember that, or is that completely forgotten?
I remember that.
Oh, good. We use this identity because I would say something like sine alpha equals square root of 2 over 2. And it's in quadrant 3. Find sine. All right, that was using an identity. Because all you did is you took what cosine equaled, and you, boom, you put it in its place, and you did some algebra, and you figured out sine was one of two answers, and that quadrant 3 told you whether it was positive or negative. That was an example of using an identity. All right, and we'll do more of those in a later section. And this one, we're just going to talk about how I can rewrite things in a simpler fashion. All right, and we'll see that on the next page. But the first thing we need to know are all these identities. All right, it looks like a lot, but it really isn't, because we should know these, which means we should know these as well. Remember, cosecant and sine are just reciprocals of each other. So if I say rewrite sine, you would just say, well, that just equals 1 over cosecant of that same value. Same thing as if I say rewrite cosecant, it's just 1 over sine. So all of these should be pretty well ingrained. All right, you should at least be able to do them. Pythagorean identities, notice how many we have there? Every one of them is based upon the fact that sine squared plus cosine squared equals 1. All right? Each of these three are just based upon this fact, and I'll show you how to develop these in case you forget them. Also, note the ones down here. These are just rewritten forms. So I just subtract cosine x from both sides, and it turns into this one. So these aren't new. They're just easy ways to recognize how I can change something. So if I give you sine squared x, you can rewrite it as this. Or if I give you 1 minus cosine squared x and I say simplify it, you're just going to rewrite it as sine squared x. So it's a lot of just replacing parts. All right, you see a big part, what can I replace that with to make it a little simpler? Tangent, cotangent, we covered those before. It's just honestly remembering what goes on top and what goes on bottom. I don't think there's a super easy way. If you come up with a super easy way to remember these, let me know. I just don't know a really super easy way to remember. It's just sine over cosine. It's just something that I just know. All right, sine over cosine tangent, cosine over sine equals cotangent. In fact, I do have kind of a way to remember it, but it's not going to help 99.9% of you. It's just someone that thinks like me. I know cotangents in alphabetical order. It's cosine over sine. Most of you are just like, who cares? I'll never remember that. But that's honestly how I remember. I remember cotangent, alphabetical order. Yes? Do you have a better way?
No, but it's opposite for the other one.
Yeah, it's definitely opposite for the other one. Yep. So that's what I remember. I remember alphabetical for cotangent, flip it for tangent. Yeah, opposite. So not in alphabetical.
Well, like in opposite alphabetical.
Yeah, opposite alphabetical. Yeah. I think the hard ones and the ones that most people mess up. So people that study, right, are going to do really well on this stuff. People that don't study and don't memorize, I mean, you're going to do terrible on all this. It's just going to happen because you didn't study or memorize it. But people that study are going to generally get all of this stuff right, but they might mess up stuff down here. And that's because we haven't really talked about this at all. And that is what we do with that negative sign that's inside a parenthesis if I'm dealing with cosine, tangent, or sine, cosecant, because there are ways to rewrite it. And the big thing is Do I drop the negative sign, or do I pull it out front? All right, so for example, look at sine of negative x. That's like if I had sine of negative 2. I could plug that in my calculator as sine of 2 as long as I put a negative sign out front. So if you ever have sine of negative x, you can rewrite it by just pulling the negative sign out front. You can do the exact same thing for tangent. You can just pull that negative sign out front, which also works for cotangent and also works for cosecant. You pull the negative out front. The odd one is cosine. If I plug in cosine of negative 2 in my calculator, and then right below it I plug in cosine of positive 2, I'm going to come up with the exact same answer. So in fact, if you ever see a negative sign for cosine, your immediate thing is going to be drop it. Just get rid of it. All right? And this is going to work for any one of these. If you ever see a negative sign inside these parentheses, you're either going to pull it out or you're going to drop it. You just have to remember for cosine and secant, it just drops. Everything else gets pulled out in front. It's hard to remember. It sounds really easy when I'm explaining it, but also you get to the test and you forget whether it gets pulled out front or you completely forget to deal with it. This is a major thing that's easy to miss because it's such a little thing, but it can be huge whether you can solve a problem or not. All right. Hint, hint, hint. We're probably going to have a quiz on this. On all of these.
Do you know when?
Yeah, probably Tuesday. Because I won't see you Monday because of the Kaplan. If you're, that reminds me too, if you're a senior, or if you're not taking the PSAT for whatever reason, we are not going to have class on Monday. All right, so you just don't show up. Everyone else goes to the Kaplan training stuff. All right, the quiz would most likely look like this. I'd probably provide this sheet. I would just say sine of x equals what? And I'll blank this out. Cosine blank, tangent blank. Because I don't expect you just to give you a blank sheet and say, write everything you know about, that'd be unfair. All right, and then I might say, I might have, I would definitely ask you just to do these three. I'll leave these blank. I wouldn't ask for these because these are just rearranging stuff. I think you can do that on your own. But this would say like tan x equals what? Cotangent x equals what? So I basically blank out all of these solutions and get rid of this. And that, all right? So you can fully expect that to happen on most likely Tuesday. Not guaranteeing it. All right, like I said, those Pythagorean identities all boil down to, can you remember sine squared plus cosine squared equals 1? And that came from our unit circle, that if I had my two xy values, that's how we got to cosine. We got to sine. And that's how we got to our sine squared plus cosine squared equals 1. We're not going to do that all over again. We're going to talk about how I can get to the other ones that are up there, because there's 3 of them. We have sine squared, cosine squared equals 1. We also have 1 plus tangent squared equals secant squared, and we have 1 plus cotangent squared equals cosecant squared. All we do to get to those is we divide by sine squared, and then we divide by cosine squared. Bless you. So if you don't have it memorized, you can get to these answers. So the first thing is, let's divide both sides by sine squared alpha. So that's all I'm going to do. I'm going to divide everything by sine squared alpha. So divide this by sine squared alpha. Divide this by sine squared alpha. And divide that 1 by sine squared alpha. Well, sine squared divided by sine squared, that's just 1, right? Trig functions they adhere to the same algebraic rules everything else does. All right, they're not brand new things that can play by their own rules. If you have something over itself, it just equals 1. This is a really important step to happen this early. Do you have cosine squared over sine squared? If I look at my identity sheets, I don't have anything squared over something squared, but what I do have is I have, if it's cosine over sine, it equals cotangent. All right, this is a big thing that people are going to forget, and I'm already aware of that. If I would have cosine squared over sine squared, it would equal cotangent squared. If I had cosine cubed over sine cubed, I would have cotangent cubed. However, if I ever had like cosine cubed over sine squared, I'd have to rewrite it. It has to be the same power on top of it. All right, it has to be, if something squared on top, has to be squared on bottom. So in this case, I do have them both squared. So I have cosine over sine, which tells me it's cotangent. It's in alphabetical order. They're both squared, so this is just going to equal cotangent squared. Same thing works for 1 over sine squared. I can find something, since 1 is really 1 squared, 1 cubed, 1 to the 4th. It's to any power I want to. Since I have 1 over sine squared, I just look at what equals 1 over sine. And 1 over sine is the reciprocal of cosecant. So this must just be cosecant squared alpha, cosecant squared alpha, and that's one more of my Pythagorean identities. Alright, so if you forget it, like you're doing the quiz on maybe Tuesday, and you're just like, I don't remember the other one, just divide it by sine and see what you get out. Same thing with cosine. We're going to divide both sides by cosine to get that third one. So I go by cosine squared alpha, cosine squared alpha, divide that 1 by cosine squared alpha. Sine over cosine is tangent. Since they're both squared, I'm allowed to say that equals tangent squared alpha. Plus cosine squared over cosine squared, well that's just 1, equals 1 over cosine squared alpha. 1 over cosine is the same thing as secant. So we're going to have secant squared alpha. That's our third guy. Yeah, Charlie.
Does it matter the order you want it?
Nope. Nope, it doesn't. And in fact, you need to realize that you can rewrite it in different orders. So there might be a time where I say rewrite tangent to something. Charlie? I might say rewrite tangent to something. You might say, well, if I just subtract 1 over here, tangent squared actually equals secant squared minus 1. In fact, that's where all of these variants come from. It's just moving stuff around. Right? Cosine squared could equal 1 minus sine squared x. And these aren't all the possible variants. All right, if I look at this first one, I can move this 1 over here, and it would say that sine squared x minus 1 equals negative cosine squared x. That isn't one of my variants, but it's going to be useful. All right? Just remember, you can rewrite all of them in any order to help you in any given situation. All right, these are the most basic ways to deal with our trig identities / expressions. All right, one of the easiest ways is I'm going to tell you how to rewrite them, and all I'm going to do is ask you to simplify them. All right, these should be the simplest. They'll be pretty easy today, but on the test, people will lose their minds when they see this because we're going to get to more complicated stuff. And it seems like if we get to more complicated stuff, as soon as I give you an easy problem, you try to put it in that really hard, difficult box. All right? If I tell you to find the sine and cosine and simplify, that's all I'm asking you to do. All I'm asking you to do is rewrite anything in terms of sine and cosine. So let's start with that. We're just going to start with rewriting these in terms of sine and cosine. Which means I can rewrite tangent in terms of sine and cosine. And if you flip your page, you're going to realize that tangent x equals sine of x over cosine of x. So we're just going to replace it with that fact. That tangent x equals sine of x over cosine of x. So I just dealt with the top one. Now I'm going to deal with the bottom one. Can someone tell me how to rewrite secant x according to that identity sheet? Liam. 1 over cosine of x. Yep, and that's exactly what we're going to do. We're going to write this as 1 over cosine of x. I did the first step. I rewrote it in terms of sine and cosine. So the next thing I need to do is simplify. We're just going to use regular algebraic things to simplify. That is, keep the top fraction, change this to a multiplication, flip the bottom one. So keep change flip tells me we're going to have sine x over cosine x times cosine x over 1. I have cosine over cosine, which just turns to 1, which means it leaves me with sine of x over 1, which is just sine of x. Anytime I ask you to rewrite in terms of sine and cosine and simplify, it's going to be a smaller thing. It's actually going to be simplified. So if you'd end here, you're not correct. That's not fully simplified. If you can't see where to go, just stop. Don't make steps up. All right? You'll get more points off if you make step ups. And we'll see more examples down here. Don't make stuff up on the test. All right? If you get stuck, just stop where you get stuck. You lose more points by making stuff up. All right, our next one's a little more interesting because it looks easier. It looks easier in the fact that they already gave me sine and cosine. The only thing I need to change is cotangent. So that's the first thing I'm going to do. I'm going to pick out things that aren't sine and cosine, which is cotangent, and I'm going to rewrite it in terms of sine and cosine. So that's going to look like, well, sine of x is already in sine. Plus, I said the only thing we need to change is cotangent. Cotangent, alphabetical order, so that's going to be cosine.
Please excuse this interruption. Chorus, students, please report to the gym at this time. It's earlier than anticipated.
That's me. Can you just continue
All chorus students, please report to the gym.
Get up, do it.
Thank you.
Get up. Get up, do it. He actually did in 8th grade. It actually
And
went
then I
pretty
taught
well.
my driver's ed class for like a week.
Does someone want to finish this one?
She did.
Go.
Oh, she finished it?
No, I just did a
I
sign.
actually no, how to do.
Come on, Teresa.
I'm sorry, report to the Performing Arts Studio. I'm sorry.
JK.
It's okay.
All right, so we didn't change our
I
cosine.
feel bad for Mrs. Reynolds. She has to do a lot.
She does so much stuff.
Like, a lot of stuff.
A lot.
She's like never stops
It
working.
really is.
And she's here all summer.
Yeah.
Wait, she's here all summer?
Yeah, she was here the entire time I was working.
Doing what?
Like,
All of your schedules and
secretary
making
stuff.
sure people are enrolling properly and doing all that stuff. Yeah, she's really busy. So on Secretary Day, make sure you give her a big.
We should be able to tip Mrs. Reynolds.
That's
When
what.
we come in late.
That's what it say. Yeah, that's a bribe.
No, it's like,
No, be like, sorry I'm late.
Slipper at 20.
Yeah, I wasn't late.
I really wasn't.
Okay,
I'd get her flowers someday.
basic algebra. Basic algebra. Nothing magical happens with sine and cosine, so I'm just going to leave sine of x. Since this is cosine x over sine of x, this is really cosine x over 1, right? So we're just going to have cosine squared x over sine of x. And that can't be simplified, because that's way more complex. Well, not more complex, but it's equally as complex as that. So what I need to do is I need to push those two things together, and then hope things simplify after that. In order to push two fractions together, I need to have a common denominator. Right now I have sine of x over 1. All right? Don't get confused, this isn't a denominator. Don't try just, I can just throw this up there because they're both sine of x. My denominator right now is 1. In order to have a common denominator, I need to multiply this bottom one by sine of x, which means I need to also multiply the top by sine of x. So let me just smush that in there. So I'm going to have sine over sine, and I'm multiplying it by that. And that's going to give me sine squared x over sine of x plus cosine squared x all over sine of x. Now I can push them together, right? As long as I have a common denominator, I can add the top numerators and just leave this on the bottom. So my next step is just sine squared x plus cosine squared x all over sine squared x. Still not fully simplified because it's still pretty big. I didn't quite make it much smaller than that. Yeah, Ken.
Why was the sign squared on the denominator?
yeah.
Yeah, that's kind of confusing.
Wouldn't it
On the
just
numerator?
be sine?
No, at the bottom.
Oh yeah, good point. Because I just
G.
decided to make it squared for no reason.
I should have done this problem.
Yeah, right? Oh, yeah, I should have just been sine of x. I guess I was more excited about that top. Because I'm going to tell you right now, what's on the numerator should be something you see every single time. You need to get in the habit of seeing this over and over and over again. What can I rewrite sine squared plus cosine squared as? What? 1. You need to learn that, and you need to see it very, very quickly.
Wait, so each of them are 1, or it's just 1 together?
1 together, because if I look at my identity sheet, it says that sine squared plus cosine squared equals
it does say that.
1. If they each equaled 1, it equaled 2, right? So I get to rewrite that whole numerator as 1 over sine of x.
Wait, isn't that just cosecant?
Yeah, which equals
Charlie, you're way ahead of the game.
way ahead of me. I'm still stuck on the denominator being sine squared.
This is a big boy.
Yeah, it was.
Oh, they get much bigger.
It's a long boy.
Oh, it gets
It is
big.
a long.
It isn't that. It just seems long now. A lot of this stuff you could have probably did in your head. Once you get good at this, you'll do most of this in your head.
One bad.
Really? I don't know if I'd ever be able to do that in my head, Mr. Payton.
Parts of it.
We'll see.
I'm just saying you can write it down, but you should be able to see kind of the steps that are coming up. Like you should have been able to see like this was cosine over sine. Oh, I'll have cosine squared in the
Yeah.
new. Like you're gonna be able to see it. You're gonna still write it out, but a lot of this you already know. Like as I'm writing down this step, I'm gonna know what to do next, and then I'll know what to do next. There's gonna be harder problems where you will be writing stuff down. You'll be like, I have no idea where to go now, and you just got to think about it for a while. But a problem like this should be you kind of know what the next step is. It basically guides you through it. All right, the very last one. You do it.
I was trying to, but I lost.
You do it.
I got one.
Okay, I just need to rewrite everything and I'm going to leave it in its proper place. Like I said, do not try to do this individually. I'm not going to put tangent x equals something over here and something over here.
Oh
I'm going to
my
write it.
gosh, I know exactly what I did wrong.
I'm
I did
gonna-
have a fraction over it.
You should. So I'm going to write it all. So tangent, that's the one that's not in alphabetical order, so that's going to be sine. And sometimes I'll just write it like this. I won't put the x's on. And then we're multiplying by cosecant. Cosecant deals with sine, so that must be 1 over sine. That's going to be all over secant. Well, I can rewrite secant as 1 over cosine. My sines would cancel out, and I'm left with 1 over cosine over 1 over cosine. You could do keep, change, flip. It would work out. You get the same answer, but I'm just going to see it's the same thing on top and bottom, so it's just going to equal the big uno.
Oh, I did something completely different.
Me too. I got the right answers though.
I did too.
It looks simpler this way.
I like it this way. It's so much easier.
Oh, your way?
Yeah.
Okay, then leave it your way.
I just like wrote it all out.
No, you did the same. You just did keep, change, flip.
Oh.
Yep, you just kept the denominator, and like I said, keep, change, flip is going to do the exact same thing. I like to keep everything in order so I don't accidentally, because when you start doing keep, change, flip, and you have long strings of things, you can flip the wrong thing sometimes.
So you don't suggest doing it?
I would suggest at the very least, have this written in this form, so when I'm grading your test or something, I can see that you had this,
I did.
and you didn't just flip some crazy stuff, and I'm not sure why you flipped it or did.
Try horizontally.
Write it horizontally?
So the division sign isn't
Oh, are you talking about like, maybe
Horizontal.
like sine of cosine?
No, like with a dot.
The
over
division
another dot.
sign, like the line with the 2 dots. That's
Ye-
what you're talking about?
Yeah.
Yeah, but in this order, right? 1 over sine divided by
Yeah.
1 over cosine. That's fine. I would try not to do that because we're gonna have big long ones,
Long boys.
and just being able to see what's on top and bottom is gonna make a world of difference. I mean, if you're good at using, it's just sometimes you get confused at what's on top and what's on bottom because you have to use parentheses, and sometimes parentheses get dropped, and then you're dividing wrong stuff. I would highly suggest doing this. If you can do this perfectly, I'm not gonna make you change it. Okay? But our answer is 1.